Thanks for watching. Here's part 2. Hopefully I can get through the rest of it. Starting with this guy. So it's just a fight between gravity on this guy and normal force, not normal force, F parallel on this guy. So let's calculate that out. So right here we would have this guy pulling with 0.4 times 9.8, which would equal 3.92 newtons. And then right here we have 0.5 times, like your F parallel right here is always mg sine theta. Draw the triangle if you forget. And that's going to be 0.5 times 9.8 times sine 40. So we got 4.9 sine 40. Which gives us 3.1, let's say. 3.9, 3.1. This one appears to be the winner. So magnitude of acceleration, we're just going to do big minus small equals ma. Same way we always do if we got two forces fighting. So 3.9 minus 3.1 equals m. In this case, we're doing big minus small on the whole system. So we're going to use the whole mass of 0.9 times a. So we've got kind of like 0.8 equals 0.9 a. So it should be just under 1 or 0.86. All right, next guy. We got this one. We want to know pulling force of the hand. Now, like many of these questions, we could apply all our formulas to just this guy, which would involve this is the forward force, which we don't know about and don't care. We could apply all our formulas to this guy, which would have a backward force of this thing, which we don't know about and don't care. Or we could apply it to the whole system, which is what I'm going to do, because that will have the hand force as the forward force to the rightward force and friction to the left. So I'm just going to treat it like one big object. So I'm going to do big minus small equals ma. Same way I always do when we got forces fighting and one of them winning. Big is the hand force. The small is friction, which is mu mg, and that's going to equal ma. So mu is 0.35. My mass, I'm going to use the total mass because I'm doing whole system, and it's all got the same coefficient. So 0.3, and then times 9.8. And that's going to equal 0.3 times 4.4. 0.3 times 4.4 would be 1.32, I believe. Sorry, this should be a minus. There we are. 0.3 times 0.35 would equal 0.105 times 9.8 gives us basically like 1. So we got F hand equals, or minus 1 equals 1.32. So F hand equals 1 plus 1.32, or whatever it is. So it should be about 2.3, which it is. There we are. Moving right along. Free body diagram below shown for a block being accelerated across the floor. We just want the formula for coefficient of friction. We don't even need this diagram. I don't know why we're bothering. Because force of friction is always just equal to mu Fn. So if we rearrange that sucker, we want to solve for the coefficient here. We would just have force of friction divided by Fn equals mu. So this is on your formula sheet. We just rearranged it and went for that guy. Oh, looks like it has crashed on me. So Give me a quick sec. Hopefully I can get it going again. All right, hopefully we're back. Yeah, there we are. Next guy. This is the one I got the wrong answer to on the answer key. Answer is A. But yeah, if you're looking at the answer key, it's there. It says in the forces loot box. Anyway, here's how you do her. First, free body diagram it like you do everything. After you throw the thing up, after it leaves your hand, it's got gravity down, which is equal to 6 times 9.8, which should equal, I believe, 50. Oh, having a moment. 58.8 newtons. And then there's an additional 24 newtons of air resistance. So in total, there's nothing pushing it up. It's just momentum keeping it going forward. So both of these guys are accelerating it down. So we've got a net force of our total uncanceled force. So these guys just added. Which would be 82.8. And then we'd want to find the acceleration because we're interested in height and we got all this other kinematics-y stuff. So acceleration is the bridge between that. So we're going to say, hey, acceleration is F net divided by m, which is 82.8 divided by 6, which would equal 13.9, I think, meters per second squared. And then you just solve for the maximum height. We're using VF squared equals VI squared plus 2AD because we don't know time and we don't want to know it. Our final velocity is going to be 0. Our initial velocity will make 15 plus 2. I'm going to make my acceleration negative because I want my displacement to be positive. So I'm just basically making down negative. So negative 13.9 times d. And so we'd end up with like negative 225, which is 15 squared, divided by 2 times negative 13.9, which is negative 27.8. And so that is going to equal 8.2, I believe. And we'll go with that. That's how it's done. And next sucker. This one's one of the hardest and one of the ones I most wanted to go over. It's not that bad, but it's bad enough. Gist is you are going to need both F parallel and F perpendicular. So we're going to find those. Remember, top angle is going to be 36 degrees. Our hypotenuse is gravity. So that is 6 times 9.8 or 58.8 newtons. All right, so then we got to find this guy, which is beyond me currently in my head. Cos 36, and this is 58.8 sine 36, because we need our F parallel and F perpendicular both here. 10 times 9.8 is obviously just going to be 98. So we've got 58.8 times 36 sine, which is 34.6. And we got 58.8 times 36 cos, which is 47.6. So a lot of numbers, but our key ones are this guy, which is our F parallel, this guy, which is our F perpendicular, and you can probably figure out what that is. Really, we got a fight between this forward force of gravity and our F parallel, which we have solved for, and our force of friction, which we have not yet. So when we solve for force of friction for fun. So force of friction is just equal to mu Fn, Fn being equal and opposite to F perpendicular here, which we found. So that'd be equal to 0.22 times 47.6. So 47.6 times 0.22, 10.47, or about 10.5. So we got 10.5. So it's really just a big minus small equals ma for the whole system, which we'll do here. Big being this guy right here, our 98 newtons. The 10 kilogram is pulling it all in that direction. So we got 98 newtons. Our small, we actually have smalls. We've got F parallel. Maybe I'll do this right here. And then minus force of friction equals our total mass, which is 16 times A. So we'll do 98 minus 34.6, which we found right there, minus an additional 10.5. This was our force of friction. That gives us our net force after we subtracted off the two forces pulling us back. That's going to equal 16A. 34.6 plus 10.5 is 45.1. 98 minus 45.1 gives us 52.9, I think. So something like 52.9 equals 16A, which will equal A equals 3.3-ish meters per second squared, I think. All right. If I'm not exactly right on the numbers, correct me. I'm doing this in my head, but the gist is all there. The answer key is also there with the actual right numbers. Inertia is directly related to which of the following quantities? Inertia is resistance to change in velocity. Inertia is determined by mass. Yeah. Things tend to keep, like first law of motion is called the law of inertia, and it's saying things tend to keep moving in a straight line at the same velocity as they were going before. And how much they tend to do that is determined by their mass. All right, here we got a block accelerating downward at 3 meters per second squared near Earth's surface, and we want to find the tension in the rope. We'll just free-body diagram it. We got mg here, which is 4 times 9.8, or 39.2 newtons. We've got our rope force here, which is what we're looking for, which is going to be less because we are accelerating downwards, so down must be winning. Anytime things are winning and forces are fighting, we are big minus smalling it. Where big is our 39.2, small is the force of the rope, and our mass is 4, and our acceleration is 3. 4 times 3 is 12. If we rearrange this, we got 39 minus 12 is 39.2 minus 12, which is just equal to 27.2. And that's our go. That is our answer. All right, I kind of already did this in the last video, but just as a quick recap, the key to all this is this little thing, which I love. The acceleration, is purely horizontal. There is no component of it that is vertical, which implies that your vertical components must be equal. Your vertical components must cancel. So if we do 100 times sine 30 to get the downward component of this guy, sine 30 is just a half, so 100 times sine 30 is 50. Our upward component also has to be 50 because they have to cancel because we're just accelerating horizontally. And so from that, you can just do 50 divided by sine 40 to find the hypotenuse, which is what you're looking for. Just for fun, 50 divided by 40 sine, and we've got 77.8, or 78 with sig figs. Next guy, we got this guy. This is another one where we could apply our formulas to just the 10 kilogram, just the 20 kilogram, or a whole system. I'm going to apply it to just the 20 kilogram one because I don't care about the hand force. And this, I don't know the hand force. I don't want to know it. I just want to find the coefficient of friction. So if I just applied it to this one, the hand force would be the big force. If I applied it to the whole system, hand force would be the big force. But if I just look at this guy, he's just getting pulled forward by 70 newtons because this force is 70 newtons. So just looking at this guy, big minus small, because it's always big minus small when you're accelerating and two forces are fighting. We've got, this is pulling with 70 newtons. So that's our big force. It's accelerating in that direction. Our small force is force of friction, which would be useful to know. And that's equal to m times a, which in this case is 20 times 2. So force of friction, if we do 70 minus something is 40, that something must be 30. So we've got our force of friction. We want to find our coefficient. Our coefficient is just equal to, like, you know, your formula, force of friction equals mu Fn. If we rearrange that, we got force of friction divided by Fn, which in this case is 30, divided by gravity, which is 20 times 9.8, or 196. So we're dividing by 196 because gravity is going to be equal and opposite to the normal force in this case. And that'll be equal to about 0.15, thereabouts. A little bit more, but that's close enough. That's how you do that one. Here's another sneaky one. Good one to know, because sometimes I throw something like it on a test. Basically, if you component diagram this penguin going down the slope, you've got F perpendicular into the slope. That's F perpendicular. You've got normal force equal and opposite out of the slope, so they cancel each other out. And you got F parallel downslope and nothing upslope because we are ignoring friction. So when I look at this, I'm like, whoo, this guy's uncanceled. This guy must be the net force. So I'm going to say, hey, net force equals F parallel. So MA equals mg sine theta. Hey, if this is true, if and only if your net force is your F parallel, it looks like your acceleration is just equal to g sine theta. Now, we don't know A, but I bet we can figure it out. We know our displacement is 5 meters, and we know our time is 1.4, and we also know it starts from rest, so we know VI equals 0. So if I want to solve for A, I might use this formula, D equals VIT. Since VI is 0, I can just forget about that, plus 1/2 AT squared. If I rearrange this, the D equals 1/2 AT squared to solve for A, I'd end up with A equals 2D over T squared, which in this case is 2 times 5, divided by 1.4 squared. 1.4 squared is pretty close to 2, so my acceleration is going to be pretty much 5. It's 1.96, close enough. So I'm going to say my acceleration is 5 meters per second squared, because it pretty much is. And so if I rearrange this to solve for my angle, I sub this in. I will rearrange for sine. So my sine theta is equal to A over G, or theta is equal to the inverse sine of A over G, or the inverse sine of 5 over 9.8. Inverse sine of 5 over 9.8 is probably pretty close to 30. Oh, geez, there's 28 and 31, though. Is it going to be more or less? It will be a little bit more. So I'm going to say it's 31, because that's how I roll. All right, next guy. Tension line joining two masses shown below is 12 newtons. We want to know mass M1. Now, so we know this force up is 12 newtons. We also know the forward force on this guy is 12 newtons. Sure would be nice if we could solve for acceleration, so we will. This is what we have the most information about. We got 12 newtons up and 10 times 9.8 down, which is 98 newtons. So we will big minus small, because of course we will. We got forces fighting. Big is 98, small is 12, and that's going to equal 10 times A. 98 minus 12 is 86, divided by 10 is 8.6. So we've got an acceleration of 8.6. Now we can just say, hey, tension is 12 newtons, and this is the net force on this guy, because we got like mg down, and we got normal force up. We got no friction, because we're ignoring surface friction. So this is the net force on M1, and we know F net just equals M times A. So if we rearrange to solve for M, we got M is F net over A, which in this case is 12 divided by 8.6, which will be slightly more than 1.25, so it'll be 1.4. There we go. Got that sucker. Next guy. We got this 2.2 can of paint projected up an inclined plane with initial velocity of 15 meters per second as shown below. So magnitude of force of friction. For this guy, we just got to find our delightful F perpendicular and our F parallel. F perpendicular will just be mg cos theta, or 2.2 times 9.8 times cos of 334, which is equal to 17.8, or 17.9 rather, with rounding. And our F parallel is going to equal to mg sine theta, because this is mg and this is 34. And so that's going to equal 2.2 times 9.8 times sine 34, which is equal to times 34. So that's just equal to 12. So we're going to find the magnitude of force of friction. Force of friction is always just equal to mu Fn, which in this case, I'm going to component diagram this sucker, because this will be useful. So after it leaves the hand or whatever launched it up the slope, you've got like normal force out, equal and opposite to the perpendicular component of gravity. We've got force of friction down, and we've got F parallel down. Notice no up forces. These guys are F net, because they are the uncanceled force, which we'll get to later. Anyway, force of friction is mu Fn. Fn is equal and opposite to F perpendicular, and F perpendicular is this. So mu is 0.15 times 17.9 which is pretty close to 18. 0.15 times 18 is equal to 2.7, I believe. And then the magnitude of the net force, we said net force is the uncanceled force, which in this case is friction and F parallel. So F net, in this case, after it leaves whatever launched it, is just equal to the force of friction plus F parallel. And we know both of those. So we know it's 2.7 plus 12. So that is 14.7 newtons. And we don't know how far the paint can slides up before stopping. So I bet you, since we want to know distance, we've got initial velocity of 15, a final velocity of 0 because it's stopping, and we got to figure out A. A is kind of the bridge between our forcey stuff and our kinematic stuff. But we know F net, and acceleration is just F net divided by m, or in this case, we've got 14.7 divided by 2.2, I believe it was. Yes. So that's 6.7 meters per second squared. And so then we can just solve for distance. We're using VF squared equals VI squared plus 2AD because we don't know time and we don't want to know time. So if we solve for D, that would equal VF squared minus VI squared all over 2A. I'm going to put A as negative 6.7 because I want a positive displacement. So that's making just downslope negative and upslope positive. So anyway, we got 0 squared minus 15 squared, which is 225, divided by 2 times negative 6.7. Negative, so it's 225 divided by 2 times, or negative 225 divided by negative 13.4. Which gives us 16.8. Should go up 16.8 meters, assuming I haven't screwed up anything. Entirely possible I occasionally screw something up. Check with the answer key. I'm doing this in my head, but the method should be correct. Falling 0.6 kilogram object experiences a frictional force due to air resistance of 1.5 newtons. What's the object's acceleration? We just need to free body diagram this and then do a big minus small. In this corner, we got gravity, 0.6 times 9.8, which is equal to 5.88 or 5.9 newtons. In this corner, we got 1.5. So this one, if we do a big minus small, equals MA, because we got forces fighting and one was winning. We got 5.88 minus 1.5 equals 0.6 times A. 5.88 minus 1.5 is 4.38, or I might just say 4.4 equals 0.6 times A. A is the same as 44 divided by 6, which would be 7.3, and we are done. That one. On to the next one. 1,200 kilogram vehicle is accelerated from rest to 15 meters per second. Already I see some kinematic stuff, so I know I'm going to be solving for acceleration. This one's nice and easy. Again, we're using VF squared equals VI squared plus 2AD to solve for acceleration. So VF squared minus VI squared all over 2 times d. All these are positive. They're all in the same direction, so I'm going to make forward positive. Again, we got kind of like 15 squared, which is, again, 225 minus 0 squared, all over 2 times 85. So that's 225 divided by 170, which is 1.32, and then F net just equals M times A, which is equal to 1200 times 1.32. Which looks like this guy. I got 1588. Well, with sig figs, we got that guy. All right, on to the next one. Still not quite done. All right. So it's a fight between the F parallels between these two guys. So I'm going to say F parallel for this guy is equal to mg sine theta. F parallel for this guy is equal to mg sine theta. And they're fighting. It's frictionless, so we're ignoring everything else. It's just going to be a fight between F parallel here and F parallel here. I'm not sure who's going to win yet. Maybe this one, but that remains to be seen. So I'm going to find the numbers first, and whichever has the bigger number wins. So we got 2.5 times 9.8, 200 or 24.5 times sine 65 will equal 22.2, and then we got 3.2 times 9.8 times sine 35, which is equal to 718. So it looks like this guy is the winner. So it is definitely down the incline. This one's going to win. And then all we have to do is big minus small. Big minus small equals MA. Big is 22.2 because it's a bigger number. Minus 18 gives us 4.2. And we're going to use total mass. 2.5 plus 3.2 is 5.7 times A. So we got 4.2 equals 5.7a, and that is going to be less than 1, so it is definitely 0.74. All right, and we got the last one, another tricky one like the one we saw before. It is, if we want to look at M2, our free body diagram is just, it's got gravity on it. Notice I'm not doing components here because it's free body diagram. It's got tension and it's got normal. Also a bit of friction. Now, we will also want to find the acceleration, and that will be a fight between gravity, mg here, which is 2.5 times 9.8, or 24.5. And we've got a fight here. We've got our force of friction, and we've got our F parallel, which are both going to be fighting it. So we got two small forces. Our F parallel is equal to 1.5 times 9.8 times sine 40, mg sine theta, and that's equal to 1.4 or 14.7 times 40 sine, which gives us 9.4 newtons our F perpendicular, which we're going to need to find which is equal to normal force. So we're going to need that to find friction is equal to 1.5 times 9.8 times cos 40, which is equal to 14.7 times 40 cos. So that's 11.3. And we'll need to use it to solve for force of friction, which is just equal to mu Fn, where Fn is equal and opposite to F perpendicular in this case. So we've got 0.2 times 11.3. 0.2 times 11.3 is 2.26, I believe. So like 2.3 with some rounding. And so we'll just do a big minus smalls. Big minus smalls equals MA on the whole system. Big, we've got 24.5, our big gravity here, pulling on this guy. And in this corner, we got our friction, and we got our F parallel. So minus friction, I'll just write in here, minus F parallel is equal to our total mass. 2.5 plus 1.5 is 4 times A. So we got 24.5 minus 2.3 minus 11.3 equals 4 times A. 11.3 plus 2.3 is 13.6. 13.6 minus 24.5 is, I believe, 10.9. Or no, 11.9. 10.9, 13.6. Sounds about right. 10.9 equals 4A. Yes. All right, so then we divide by 4. And so that will, A is equal to 10.9 divided by 4, which is just equal to 2.7. 2 kind of thing, or whatever, 2.7. Let's go with that. There we are. Hopefully that is accurate and has helped. Thanks for listening. Hopefully this helps.